For all of human history, I could only stare at the sun from a safe distance, our blazing, life-giving inferno. But in 2021, something extraordinary happened. For the first time, a spacecraft touched the sun's atmosphere. This is the story of the Parker Solar Probe, the little craft that dared to fly into the fire. The sun is a monster. Its core burns at 15 million degrees Celsius. The surface? About 6,000. But the outer atmosphere, the corona, reaches into the millions. That's also where the solar wind is born, rivers of charged particles that stream across the solar system, shaping auroras, scrambling radio, knocking out satellites, knocking out power grids. So what exactly is the corona? It's a thin, super-hot halo of plasma surrounding the sun, threaded with magnetic fields. Understanding it matters because space weather starts here. Better predictions mean safer astronauts, sturdier satellites, power grids that stay on. But for decades, one big mystery lingered. Why is the corona hotter than the surface beneath it? From Earth, that answer was always just out of reach. Getting close to the sun is brutally hard. Gravity yanks you inward at terrifying speeds. Heat and radiation try to melt, fry, and erase anything you send. For years it seemed impossible, until Parker. Launched by NASA in 2018, named after Eugene Parker, the visionary who predicted the solar wind, this probe set a bold goal: fly within about 4 million miles of the sun. To survive, it carries a carbon-carbon heat shield that shrugs off temperatures around 1377 degrees Celsius, about 2,500 degrees Celsius. Parker flies so fast, up to 430,000 miles per hour, that it's the fastest human-made object ever. And it thinks for itself. When radio signals from Earth are too slow, Parker automatically tilts its shield, steers, protects its instruments. Then came December 2021. Parker slipped into the corona. The first time in history any craft had done it. It didn't melt, it measured, it listened. It sampled solar plasma directly. It found magnetic switchbacks, kinks that whip the wind and help explain how energy moves outward. Those clues feed into the big puzzle of why the corona runs hotter than the surface and how solar storms ignite. The result? Better forecasting of the tempests that can threaten our tech and our crews in space. And the journey isn't over. Parker rides gravity like a surfer, stealing a little momentum from Venus on each flyby, spiraling closer, orbit after orbit. By 2025, it reaches roughly 4 million miles from the surface, 7 times closer than Mercury. Each pass means more data, sharper models, new ways to shield future explorers from the sun's moods. Why risk touching the sun? Because understanding it protects Earth. Solar storms can jam GPS, blind satellites, and strain the grid. Parker turns guesswork into forecasts and reminds me of something bigger, that curiosity is a heat shield of its own. It lets us venture into places no life has ever been. One tiny spacecraft, skimming the edge of a star, handed us a first, the touch of our sun. Parker proves the age of exploration isn't over. It's only just begun. If you could send a probe anywhere in the solar system, where would you send it? Tell me below. And if this lit a spark, subscribe, like, and share.